members, CityLog. One of our corporate members, CityLog, to speak to us on the topic of application of AI deep learning in today's advanced smart traffic solution. And with us today from Paris, France, is the CEO of CityLog, Mr. Eric Toffen. Before we start, may I request all audiences to mute their microphones so that we can minimize any disruptions to the presentations. Questions are more than welcome. Please type your questions to the speakers in the chat box. We'll be reading them to the speakers at the later part of the event for their feedback and discussion. Now I'll hand over the floor to you, Eric. Thank you.
Good morning. Thank you. Thank you very much for hosting me and giving me this opportunity to share what we do at CityLog and how we think we can help in Hong Kong and other countries around the world with our technology, and particularly this morning share what is our experience of using deep learning technology for various fields of video detection. So first of all, a few words about CityLog. What we do at CityLog and what we have been doing for more than 20 years, 25 years to be exact, is applying video detection to the traffic industry. So we wake up in the morning, we think traffic. We go back to sleep in the evening, we think traffic. So we're very traffic focused, and really the core technology that we develop is everything that revolves around video analytics and video detection. We are headquartered in Paris, France, and we belong to the Tagmaster Group since April of last year. And we have the Tagmaster Group being headquartered in Stockholm, but I would say the bulk of the people within the Tagmaster Group and within CityLog are really well distributed around the world, and we have an office in Hong Kong. We have been deploying over the year more than 1,000 sites of video detection around the world with our various applications. So we've been around for quite some time. So basically, what we do, we apply the video analytics to, I would say, three major categories of applications, which are incident management, traffic efficiency, and traffic statistics. So if we look at the incident management, the goal of video analytics for incident management is to assist the traffic operators who are monitoring the traffic infrastructures. So we're talking tunnels, we're talking highways, we're talking bridges. And in most cases, with a few exceptions, but in most cases, traffic operators are looking at hundreds and more thousands of cameras covering various road infrastructures. And of course, it is very difficult for one or several traffic operators to keep an eye on everything that is going on the infrastructure. Have a look at all the cameras. Most of the times, the cameras are cycling on the video wall, and it is very difficult to pinpoint incidents and accidents. So most of the time, operators will be made aware directly or indirectly of an incident or an accident. But what the video analytic does is it provides for the infrastructure the ability to monitor it 24/7 and detect and report extremely quickly incident and accidents. So the way it operates is we use the video cameras that are deployed on the road infrastructure, and we detect any trajectory, any movement of object that is not consistent with, but is not a normal behavior on the road infrastructure. So in this case, we detect a vehicle that comes to a stop. And then what happens, or two things happen. First, the system will record a digital video clip of the accident. Let me replay that. It will record the video clip, that the one that you're seeing. That is whenever it is possible to record. In some countries, there is no recording. And the second thing is, it will pop up an alarm for the traffic operators within a few seconds following that incident. So the alarm will pop up on the video wall, will pop up on the operator's workstation. It may or may not create an audible sound, but the idea is to focus the attention of the operator on that particular camera where the accident has happened. And then the operator is gonna assess the situation, maybe replay the video clip to understand the circumstance of the accident or the incident, understand if this is a serious issue, and replaying, for example, that video clip is gonna see that the shock is quite violent. So on top of the highway patrol, on top of the tow truck, is very likely to send directly an ambulance on the site as a preemptive to make sure that we can take care of people. So that this is what the video analytics system is for incident management: quick alert, but also giving enough information through the video clip to for traffic operators to react efficiently. So we've seen an example in a tunnel, and of course we've deployed a lot of systems in tunnels, because if you have a road infrastructure including a tunnel, a bridge, and a section of open highways, most probably your assessment is going to be that the tunnel is the most critical infrastructure, because once people are in a tunnel, then if something happens, there's a lot to consider in terms of risks. So I would say this is the reason why we've deployed a lot of tunnels around the world. But the highways and bridges are also critical in their entirety or in some sections, and we've been able to apply the same technology to the highways. And I will discuss later on a little bit more in details how we can using the deep learning technologies has completely changed. I was going to use the word revolutionize, but let's be a little bit more modest and say completely changed the way we look at incident detection outdoors. So you first saw an example of a stopped vehicle. Here's an example of a wrong-way vehicle. Obviously, wrong-way vehicles do not happen very often, and that's a good thing. We do not want those incidents and accidents to happen very often. But when you have an occurrence of a wrong way, it is very important to detect and act upon it quickly. So we saw a wrong way on an open road section. Most of the time, we try to detect the wrong way when they start occurring, which is at the off-ramp of the highway, and this is 99% of the time how people enter the highway on the wrong way. We saw an example of pedestrian detection or fallen object detection, and here's an example of slow vehicle detection. So slow vehicles are also a hazard for themselves and for other drivers. So it is important to detect them and to be able to send a highway patrol to help them get off the road and protect them. An example of loss of visibility detection in a tunnel, which is most of the time associated with the emission of smoke in the tunnel. whether it would be a fire or a vehicle, a fire of the structure, fire on a vehicle, or sometimes a bad exhaust on a vehicle. And last but not least, detection of congestions and traffic slowdowns, which are very important, so that we can warn the drivers coming to the slowdown, warn them very dynamically and quickly to slow down, so that this congestion doesn't turn into an accident. So those are the various incidents that we can detect. The second application that we have for video analytics is the traffic efficiency, which is optimizing the cycle of the traffic lights in order to optimize the traffic flow. So I'm not going to go into details on the operations of a traffic light, but the goal is to detect the vehicles that are at the intersection in order to provide more green time for the directions of traffic where there is more vehicle, and skip some phases where there are no vehicles. So in most part of the world, this consists in replacing the magnetic loop technology that we've been using since the 60s, and replace them with video detection, with the goal of having a non-intrusive solution, which is not damage the road and not having a problem of reliability of the loop over time, because the variation of temperature, and I know in Hong Kong it's not a question of having snow and defreezing, but this is what we have in more northern countries. But it's also a problem of the road work, the wear of the road that is going to wear the magnetic loops over time. And when you have a city that is very busy, it is a problem to shut down the road, close the road to do the maintenance or the replacement of the loops. So this is why the video detection has been very familiar. So here to detect the presence of vehicles at the stop bar, but also to be used in some schemes where we are really targeting optimizing the traffic flow, and most of all avoiding the gridlock of the intersection. So this is an example of what we don't want to have. This is the gridlock of an intersection in Paris. So you have the flow of the vehicles coming from the top. They have the green light, but at some point they should realize that they should not go through because the traffic is blocked. So they block everything. They block themselves. They block the tramway, and the tramway is going to block the other flow of vehicles. So it's at the start bad behavior of the drivers, but this happens in some regions of the world, and unfortunately this happens in Paris and in France. So the idea is to detect this by detecting the presence of vehicles stopping at the center of the intersection, and when we detect this, we put all the traffic lights to red, empty the center of the intersection, and then resume the normal cycle. So this system of anti-gridlock, pre-gridlock detection is deployed of all the intersections with the tramway in Paris. And of course, these days, intersection control is also about managing pedestrians. It used to be only about vehicles, but now it's about managing pedestrians. So detecting pedestrians on a crosswalk in order to extend the green light whenever is necessary. And also bicycles. For a lot of countries in Europe, and I would say for a lot of North America, bicycles I mean, significant numbers of bicycles in the cities is a relatively new thing, with a few exceptions. So if you accept the Netherlands and Copenhagen, most of the other countries in Europe, for example, have experienced a surge of vehicles with the COVID and the lockdown. And so we are adapting the infrastructures and the cycles of the traffic light to this. So reliably detecting the pedestrians has become a must for intersection control solution. And the third application that we have is the traffic statistics. So basically collecting traffic data using video analytics with, I would say, several possible different purposes, which is the real-time traffic information for the road users. So collecting the data to inform people of travel time, of delay, of congestion, and then the offline use of traffic data, which is to perform some statistics to understand through the passage of different vehicles what is the foreseeable usage and wear of the road infrastructure, to plan for resurfacing, or the increased usage of traffic that is going to necessitate at some point to increase the road capacity. So very simply, it's again a question of replacing a technology that has been used for years, which is the magnetic loop. Other technologies exist for this kind of applications, such as the radar, but with the video detection and now the usage of the deep learning, it's become extremely easy to count vehicles, measure the speed, occupancy, so do everything a loop does, with on the top of it a better classification of vehicles that is today based on length, but with deep learning will be based on true vehicle classification. So I would say the video detection has, for the most part, not been the technology of choice for pure traffic statistics. But with the deep learning, I think it's going to become one of the dominant technologies for this application. So in terms of solution, how do we deploy the analytics? So for the most part, there are two choices. One is to deploy the video analytics on a server, and one is to deploy the video analytics inside the camera. So it's an edge detection. So for the first solution, having any camera already deployed, it's very easy. We stream the video to a server, and this server is going to host the video analytics, process the video, create the alarms or the traffic statistics, create all the data, record the video clip, and is going to send this to a central server, and that central server is going to host all the configuration, all the backups, is going to be used to perform the maintenance, and it's going to be used to communicate to any third-party systems or SCADA or ATMS, any central traffic management system, and it's going to be also communicating to a number of workstations that can host the interface to the traffic operators to give them the incidents. The other solution is to host the analytics on cameras. So some cameras technologies have the ability to host video analytics if they have enough resources. So when we talk about resources, we talk about memory. Like on a computer, we talk memory, we talk CPU, and with this ability, we can run the analytics and send the alarms directly to the central server or to a third-party system. And I would say the edge detection, there are some projects where you could go either way. It doesn't really matter. Both architectures are possible. I would say the edge solution is extremely useful in cases where the connection that or the network that we have between the camera and the traffic control center is either a cellular communication or the bandwidth is not so great. Then it's good to have detection on the edge, so you don't have to stream the video 24/7 from the camera to the traffic control center. So we've been using this technology a lot for remote locations. The example I was talking about with detecting the wrong way vehicles at the off ramps is also one application for edge detection. When we talk about intersection control and traffic efficiency, as of today, we do only edge detection because the architecture and the system, the intersection control system is more prone to have everything hosted in the camera. And for the traffic statistics solution, we have both solutions, edge-based or server-based. And I would say whether an edge-based or an server-based architecture are chosen, the performance is exactly the same. The performance of the video analytics is exactly the same. So it's completely transparent to anybody who's looking at the results, the alarms, or the detections of the system. It's purely a matter of what architecture will suit best a particular project. So now let me switch to the topic of the day, which is the artificial intelligence and deep learning. So first of all, we should say that artificial intelligence is not something extremely new. So we've been talking about artificial intelligence for quite some time in science fiction and in real science. So we can see that as far as the 1940s. There was already artificial intelligence being discussed, but I would say what is the basis of what we are using for the deep learning branch of artificial intelligence is something that started in the 80s and really boomed in the years 2010 and after. So I would say at CityLog, we've always used artificial intelligence. So since we've been created, so we've always applied artificial intelligence to detecting incidents, and in that definition, the artificial intelligence is a computer program that will perform a task that a human being could perform. But I would say if we choose smartly, we use the artificial intelligence to perform a task that might look very simple, but for which it will either be better or faster than a human being in some circumstances. At some point at CityLog, we've started to use machine learning, which is on top of the artificial intelligence layer. You add techniques that allow the algorithms to be improved over time as they are exposed to more data, and all the data come from this experience that we've had over the years. And in 2017, we started to use deep learning, which is a subject of today. And the deep learning, and we're going to see it in more details. The deep learning basically uses technology called neural networks to better identify objects that are being detected and classifying them. So the question is, since this technology has been around, we've talked about it for now more than 10 years. Why is it booming just now? So why did CityLog did not use this before? So it's a conjunction of several factors. One of the factors is the availability of what we called data sets, which is a bunch of pictures. If you wish, databases of pictures over the internet. And you can see this in your everyday life when you use your computer and internet. There are stored pictures of everything all over the internet. The second thing is one technology which is called GPU. G is for graphical, so it's like the CPU of your computer, but in a graphic board. So this is used mostly. This was mostly developed for gamers for video games, but and deep learning can be applied without those GPU, but it's much more efficient to deploy it with a GPU. So the conjunction of those two occurrences created the boom for deep learning. So it doesn't mean that it was not possible to do it before. It became more industrial in a sense that you would be able to do this on a regular computer, as except to using a supercomputer. If you are using supercomputers, then you cannot apply this technology for every day. So we would not be able to deploy this technology for ITS. So if we look what we are trying to solve with the deep learning. So if you look at a traffic control center, so I didn't choose a small one. This is a big traffic control center with a huge screen. But even if you have a more modest traffic control center, it remains the same thing. So you have traffic operators, and the traffic operators are not very good at one thing, is because there are so many cameras. They are not going to be very good at making sure they detect everything that is going on any camera extremely quickly. So because they're there, and my brain and everybody's brain is somehow limited, and we have not the ability to display all the cameras all the time on the video wall. So that we will, as a human being, we will be challenged to keep an eye on everything. But the traffic operators are very good at one thing, which is once they are being reported an incident, understand from the pictures that they are seeing how serious the accident is, analyze the situation, how many vehicles are involved, and then understand what they need to do with this situation. If you look at the machine, if you look at the computer, the machine is going to be on the opposite, extremely good at quickly detecting everything that is going on. It's looking at every cameras 24/7, so it will detect extremely quickly. In some extent, it will be able to interpret the incident and the situation. So it will make the difference between the stopped vehicle and isolated stopped vehicle and the traffic congestion, or between a slow vehicle and the wrong way vehicle. But it will not be good at interpreting the image very finely. It's not going to be, as of today, maybe it will evolve in the future, but as of today, it's not able to say this incident is very serious, or this accident has likelihood of injured people in the car, which a human being will be able to do. So what we're trying to do is tailor the deep learning so as to, let the machine do what it's good at, and let the people do what they are good at, with the assistance of the machine. So we are always looking at this balance. So how do we implement deep learning? So to implement the deep learning, you are going to need a deep learning model that you will need. So you could build it from scratch, which is extremely complex. You will need database of pictures, and you will need computer power. And on top of that, you will need some time to train your algorithm and make sure it is good. So what we typically do is we use a pre-trained neural network that can be found on open source, off the shelf on the internet. You input a picture in this trained neural network, and you could do this if you have a little bit of computer ability. You could do it yourself. You input it, and this just off-the-shelf neural network will be able to tell you, well, I see a road. There's 98% possibility this is a road, 97% possibility this is a car, and so on, up to some more fancy things. We think it could be a racetrack, 95%, and so on. But it's not good enough for what we want to do. So usually what we do is we create a specialized neural network. So you take the off-the-shelf neural network, and you input a specialized data set, which is data specific to what you want to achieve. So in our case, traffic data, and we have 25 years of traffic data that we can use to specialize our neural network. And then over time, we create what we call a trained and specialized neural network that will be dedicated to our application, and in that case, in incident detection. So you see a lot of, when you walk around, when you go to traffic shows, you will see a lot of hype around neural networks. You see all kind of videos, all kind of people detecting things. Most of the time, those are from off-the-shelf neural network, and they can do a relatively good job, as you can see in the video. But the question is, will they be able to do a good job with the camera placement that you typically have for the ITS? Will they be able to perform in all kind of situations: day, night, rain, sunshine, shadows, snow? Again, not typically the case in Hong Kong, but in other countries that is sandstorm in other countries, and most of the time it doesn't take very long to put those off-the-shelf systems to the test. So to go from a neural network that you take off the shelf to a solution, so you need the technology. You need to have a good basis of the technology, and to go to the solution, you need a lot of experience and a lot of material that is pertinent to your industry, and in our case to the ITS. You need a good team, which I think we have. You need to integrate that solution, and you need to implement on real site to test your solution. So I see I'm running a little bit behind. So let me skip a couple of slides to focus on the results. So we talked at the beginning of our presentation that we had deployed a lot of incident detection systems in tunnels. And one of the reason is because it's the most critical infrastructure. And the second reason is also because when we deployed incident detection in tunnels, we had very good performance. Although if we listen to our customers, it can always be improved, and it's always good to improve the performance. But basically the detection rate, the occurrence of false alarms made the system manageable in a tunnel and reliable enough. When we deployed on outdoor, before we used deep learning, what we had is we had good detection time, very fair detection rates, but the false alarm rate was, the frequency was something like on average 10 times higher than in a tunnel. And so it's on average. So some sites were lower than this, but some sites were even higher than this, which made it difficult to use the system. So the first, the picture you see on the right-hand side is the Millau Bridge in France, in the south of France. And when we applied the deep learning to that site, it's the first site we deployed. We reduced the false alarm by 90%. So we divided the number of false alarm by a factor 10, which is a huge achievement, and made it extremely close to what we have in a tunnel. So we basically, through the deep learning technology, through the ability of reducing the false alarm, we took it from a system that was difficult to operate, from a system that is very easy to operate. So that was the first algorithm of deep learning we released in 2019, and we just released. So this workshop is very timely because we just released end of last month a second generation of deep learning algorithm. And in this deep learning algorithm new version, what we are making the most of is the ability of the deep learning to reliably identify what type of vehicle we are detecting. So now when we get an alarm, not only can we say we have a stopped vehicle on the side of the road or on the tunnel, but we can say we have a motorcycle stopped on the side of the road, we have a bus stopped, we have a truck stopped, which is a big help for the traffic operators to understand what is going on. And on top of that, we have the first generation of deep learning algorithm was applied only to the outdoor. And the reason was because we felt we had satisfactory performances in tunnels. And the second generation, we decided to apply it also to the tunnel. So we had to use a lot, as you understand from the method of building the deep learning technology, we had to reteach the algorithms, the tunnel environment. So it's a brand new job, because the field of view from a camera in a tunnel is very different from the field of view of a camera outdoor. So we retrained it, and what we did is we on the outdoor, we managed to increase the detection rate, which was not the target of the first release, but we managed to increase the detection rate. And in the tunnel, we increased the detection rate, and we reduced the number of the frequency of false alarm, not in the extent that we had done in the outdoor, because we came from a system that was already producing a small number of false alarms, but we still managed to increase it. So I would say with the deep learning, we've managed to increase a lot the performance, both in tunnels and in the outdoor, and add a layer of information, which is the class of the vehicle that has stopped. So I've already showed you discussed what we did with the Millau Viaduct. Millau Viaduct is a very old customer of CityLog. We deployed the first system with them in 2005. And they have lived for, I would say, close to 15 years with a system that was challenging to operate because of the cable stage bridge shadows that would create false alarms. Installing deep learning for them has completely changed their experience with the system, with an extremely low level of false alarm now. One of the first very large scale project we deployed was in Hong Kong, actually, with the TD 93 project, and in that case it was edge-based video analytics. So we applied the deep learning, and for that amount of cameras on the project outdoor, it is extremely important to have a low level of false alarm, because it's a large number of cameras. And the project we did last year and finished implementing this year is a project in Egypt, 700 cameras. So again, that project, we would never have been able to deploy it without deep learning, because the level of alarms would have been too high with the previous technology. So it's I think the deep learning has taken us to, I would say, a new era into video analytics, which is the era of deploying the technology in an efficient way on the outdoor. So most of the projects we see now are outdoor projects to tackle the bridges, and the highways. And if I look at the technology of deep learning, so we've seen, I'm going to skip a few slides, but we've seen with what we have done with the incident detection. But I would say now what we are targeting more and more is the cities, with a high demand for reliably classifying the vehicles, so doing traffic statistics inside the cities, understanding how the different classes of users, vehicles, bicycles, pedestrians operate, and apply this to either the fields of collecting data, so traffic statistics, or applying this to the field of acting on traffic, so acting on the reliability, fluidity of traffic, mostly through the field of intersection control. So there's still a lot to do in our field. So we never stop innovating, and other companies keep innovating, which we think is what makes the ITS what it is, and interesting. So this is it for my presentation, and I understand we have a little bit of time for questions.
All right, thank you, Eric. So I see several questions posted. First of all, there's a question asking for the working website for CityLog. Seems can access the CityLog website.
Okay, so it's just citylog.com. Citylog.com is the current Citylog website. I haven't checked this morning. It should be up.
Okay, right. No problem, because after this webinar, we will actually be sending some presentation package to everyone, and so maybe that will include the website as well. Okay, so the next question is.
It is working.
No, right. Okay.
You scared me there for a while.
No problem. Right. So yeah, the next question is there was a data about the false alarm on open highways and bridges. So the question is asking, was it 2.5 camera per day, or was it 2 to 5 camera per day for highway detection?
Oh, it's the data I showed was 2.5 false alarm per camera and per day. So this was what we had before we applied the deep learning.
All right. So that was decimal place. So that was from 2.5 false alarm per camera per day,
yes,
down to 0.5 with the first set of deep learning, and then it could actually go better to 0.10 to 0.25 per camera per day.
Yep.
Okay. All right. Well, the next one is an internal question to us, is how can we access the recording? So as I said, we will actually be passing out the presentation package to all who registered at the end of the seminar. And for the recording, just send an email to ITS admin, and they will pass you the link to the recording. Okay.
Okay.
Okay. And next, there was a question on, would it be possible that the deep learning technology can enable the system to detect a person entering the highway?
Yes, as of today. So what we are trying to do is introduce little by little different functions using the deep learning. So we started with the stopped vehicle, which is obviously the most important part of the incident detection and the most critical part. And little by little, we're extending to new detection. So we already detect people on the highway. We are applying now the deep learning, and we'll be releasing a deep learning based pedestrian detection, I think, in 2023. The difficulty with what limits us on the pedestrian detection, I would say, is the size of the pedestrian. So and it is even more critical with the deep learning that it was with the machine learning before, is that to reliably detect a pedestrian, you need a minimum number of pixels. So even if we have HD cameras, it's going to limit the depth of the field of view where we can reliably tell that this is a pedestrian. So as of today, the limitation is something like 80 meters coverage to detect the pedestrian. And we think our preliminary results show that it's going to keep the same with the deep learning technology, around 70, 80 meters to detect the pedestrian. But yes, this is something that we are working on, and the preliminary results are actually pretty good.
Okay. Right. Well, the next question is, do you deploy thermal camera technology to your system?
So for as far as Citylog is concerned, and it might not be the case for all manufacturers, we have decided very early, and we've tested the thermal camera. So we think the thermal camera are very good at one thing. It is to detect a human being or an animal in an environment at night when it's very dark, without lighting, in an environment where people are not supposed to be. So this is why it's so much used for security and perimeter protection. So trying to detect intrusion of people. So I would say for this usage, the thermal camera is perfect. When we talk about the ITS, I think there are several things that make the use of the thermal cameras either not so good or not useful. First of all is because when you look at the picture from a thermal camera, you don't see a good definition of the vehicle. So it's not as easy to apply the deep learning technology, and not as efficient to apply the deep learning technology to the thermal imaging, because it's difficult to have the details of a vehicle. So reliably classifying a vehicle between a truck and a bus, and so on, is a lot more difficult with the thermal camera. The second thing is the benefits that you would get from using the thermal camera into to reducing shadows and other phenomena. You can take care of it with the deep learning. So the deep learning shows actually better result than just applying thermal camera. Then you have the definition. So all the thermal cameras by build have a lower definition, which is a lower number of pixels on your image, which means that you will reduce de facto the length of the usable field of view with a thermal camera, which I think is detrimental, because that means that you would have to deploy a lot more cameras for this. Another factor is the cost. A thermal camera is a lot more expensive than a visual camera. And then last but not least is for traffic operators. It's very difficult to manage a system with thermal images, because it's very difficult to recognize one vehicle from one camera to the next. So it would require to put visual cameras on top of that. So I think it's just first and foremost, it's not as efficient as a visible camera with deep learning, and then it's more difficult to operate and more costly. So that's the reason why for us, it's not a technology of choice for ITS.
Okay. Now, next question is, does CityLog play in the clean air zone, congestion charging spaces?
I'm not familiar with this. So
sometimes they do have it's for traffic management of congestion charging zones. Has CityLog been involved with this?
Okay. Oh, so okay. So like like what they have in London, when if you have a clean vehicle, you can enter. So no, we don't really play in this, because for us, with the deep learning, we don't have the possibility to classify the vehicles to say this is a clean vehicle that has the right to enter, or this is not a clean vehicle. And on top of that, even if we did identify it, the field of view that we have for our technology is not the field of view that you have for an enforcement system, being able to read the license plate. So we don't play at all in into the enforcement. I don't know if in the future, with the deep learning, we will be a lot more accurate and we will have a lot more possibility to play in this field. I don't know about this.
Okay. Another question is, how does this AI system integrate into third-party systems?
So everything that you see on a CityLog system, whether we talk about traffic statistic, incident management, or traffic efficiency, is really designed to supply all the data to third-party system. So in case of traffic efficiency, all the data, everything is going to go to the traffic controller or to the central traffic management system, usually through open SDK. So in case of traffic efficiency, we use industry standard protocol, and also a combination of proprietary protocols. In terms of incident management, we use various different protocols. I would say as of today, most of the time we use OPC to connect the incident management server to the traffic management system. So It's your the industry standards, the UNEX, the CAPS, the CSA, all the traffic management system that you can that you can imagine. So all the alarms, all the traffic data, all the status system status are available through this SDK. And I would say 2/3 of the CityLog incident management system around the world are operated on third-party system. I would say 1/3 of smaller systems are operated with a CityLog GUI, but the majority is third-party systems.
Right. Next question is, can the system use any other feed besides video camera feed? For example, thermal. I think you mentioned about thermal, radio frequency, etc.
It's only going to be visible camera. So in the case of CityLog, so other people, so you could use artificial intelligence with different sources. You could use it on LiDAR, on radar, on all kind of feeds. But at CityLog, we're really focused on video detection.
Okay. All right. Next question is, can you share more about the coming new technology development for CityLog solutions? So what's the new technology?
Yeah, the last part of my presentation was really about the upcoming deep learning. So everything that we do now, we do not have any track of work that does not involve deep learning, because it makes everything we do. So it's a lot of work, of course, it's a lot of investment on our side, but the result is really worth it. I think on the way it has completely changed the way we look at incident management outdoor. So it's the same for traffic statistics and traffic efficiency. And so intersection control. So everything that I've shown you, so which is reliably classifying the different users, the bicycles, the pedestrians, different types of cars. So I think the future is about adding new categories of vehicle and users. So some of them are, and also keeping in mind that we want the system to be reliable. So you don't want to classify with an accuracy of 20%. So you need to combine diversifying the classes of vehicles and users, but still keeping a relatively high reliability so the system can be usable. So this is the balance, but this is more classified users to more applications.
Okay. All right. We are nearly about time, so I'll give you one last question from the floor. How does more powerful of deep learning capability and better image quality of the camera impact to CityLog's solution performance?
So I would say, yes, one thing I didn't mention is, of course, with the deep learning, the quality of the image is extremely important. And one thing that we have also benefited to apply our technology is, I would say the cameras of today are completely different from the cameras of 10, 15 years ago. So when I started at CityLog, we were using analog cameras. And after 10 years, those cameras were completely worn out. The image was completely washed out. So we sometimes had to do incident detection on video quality that I would qualify as not very good. So we were still managing to do this, but as of today, if we can still handle relatively bad video streams, but the higher quality the video stream, the more efficient everything that is around the deep learning. So the cameras that have low light sensitivity, that give you a very good picture in pretty dark environment, all the image processing that is already done in the camera and that refines the quality of the picture. This is very important and contributes a lot to how performant we've become with the video analytics. So I would say the choice of the camera is very important.
All right.
And I see we ran out of time, but
No, actually, there's one last question which is quite relevant. It's what is the lowest camera solution FPS usually required for the system to work properly?
So to apply deep learning, the lowest resolution that we have is D1, which I think is the other name is QSIF. But I can exchange more. I don't have the exact number in mind, exact line resolution. But I can exchange with you. You can reach out to me directly, and if we can help you work on specific projects, or if you have specific questions, I'll be very happy to help you. And with whatever I cannot help, I will ask for help from my team to help me answer the more tricky questions.
All right. So thank you again, Eric of Citilog, for this informative presentation. So I'm sure many of you will have some further questions. After this webinar, we'll be sending excerpts of this afternoon's presentation and with the contact details of Citilog, so you may directly approach them for more technical details afterwards. And for those who have registered, we will be emailing you the CPD certificates for this event. So this is the end of today's webinar. The next of this series will be featuring ATAL on the topic of autonomous vehicles. So please stay tuned to our emails and communications later on for further details of the next event. In the meantime, thank you again and see you all next time. Thank you. Have a good afternoon.
Thank you very much.
Thank you. Bye-bye.
Have a good day.